January 6th, 2024. Makeup. Lights. Camera. Action. Geometry is motion. In Moment in Motion today, the theme is that geometry, the world measure, geometry, geometry, is motion, movement, the motive, change. So how can that be that those two different things are the same thing? How can it be that they're conflated to describe a sort of concept relating both that geometry is the fixed and the proportion and the angle and the measure and the meter and the form of things, and motion is a change of things, that the only constant is change. It's much like that the only constant is change, because that moment and motion reflect on geometry and flex, or the symmetry flex, and the continuum of things, the manifold, or manifold of things, helps effect to relay the concept of that there is a sort of assumed dichotomy, branching of things from a whole, from a monist oneness of things. Plato's one, Leibniz's monad, for his monadology, and his reflection on the nature of the thing. Kant's Sein, and then to das Sein for Heidegger, but then for nothing, and then Hegel's great enlightenment of the dialectic, and Heidegger and time, the continuous, then chance and uncertainty. I've been much enjoying reading D'Espagnat's philosophy of physics these days. It starts very tentatively and without much to say except entrenching a wide variety of philosophical concepts, and then gets into the whole development of the progression of why the philosophy of science needs to kind of bring back the teleological to provide for the ontological, a unified sort of approach for truth. It's a theory of truth, that truth is regular, geometry is motion. So today what I figured to do was just kind of consult these sort of grab bag of inspirational sources, and from them just see what I might find in them about these kinds of things. So from Greek Science, it's a book by Benjamin Farrington, from a Cork IR, University College Cork, Trinity College Dublin. Pelican Books, a nice little imprint. First, part one published 1944, new edition 1949. Well, he's about 2,000 years since, the original arrangement of these things. And what he describes is that he says, for example, in the second place, progress in interpretation of the scientific writings of the older civilizations has gone far to abolish the claim of the Greeks to priority or to uniqueness in the creation of abstract theoretical science. So that reflects on that before the Eleatics, 500 BC, to the Greeks, 0 or 100 BC, to 2500 BC, or the flood, or 4000 variously when it's measured, or after the flood, and then the Babylonians and the Egyptians, and for example, as from the East, that a lot of influences arrived to the Greeks, then that we are in the inheritor of their collected learnings of these. They had laboriously gathered together their hardly scientific knowledge during long centuries. We are more inclined to remember that in science the first steps are the most difficult. This is why it's so necessary to provide a linear curriculum standardized for everybody, so that they can arrive at a place where A, their thinking skills are cultivated, and B, that they are experienced with the wide milieu of the language of science. So number sense and word sense must be cultivated and developed so that then they can arrive at an object sense themselves and be free-thinking, rational individuals with open minds. This goes a long way towards making a scientist, I imagine. View the achievement in mathematics and mathematical astronomy of the Babylonians. And for example, when you consider how like the ancient architects and builders arrived at north and south and these kinds of things, basically be a study of the sky is quite amazing. And arts and crafts. We're looking here. This book is about science, and with respect to mathematics and geometry, we would point to Euclid probably, because Euclid is a panel. Euclid of Megara, he was a man, and he's also a panel, and to him is ascribed all the books called Euclid's Elements, where Euclid Elements, at one point in time after the Bible, was the most printed book in the world, and it was the textbook for a couple thousand years for this linear curriculum. And when we still have it today, and it's called The Introduction of the Compass and Edge in Classical Constructions, after the notions of congruency and the definitions, and what result from making the graphical and diagrammatical, and that everybody can freehand their own geometry. It really speaks to the great thing that is graph paper, which has kind of got a lattice already drawn on it. So then when you want to make things that are square and regular in this way, it's easy to follow the lines, as it were. Connect the dots. Paint by number. These things. So it's not meant to be any particular profound concept. Geometry is motion. It also reflects on the logical. We have the constant. Only constant is change. There's only one parameter, one variable at the very, 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 very fundamental. There's only one variable and one quantifier, and so it's essentially then broken out into one variable and one quantifier into infinitely many. Each one of these constants and variables, infinitely many quantifiers in front of them. That's the equation, the form of the thing. Anaximander, Anaximander was of prime importance to the development of all these things. Indeterminate substance. The third thinker, Anaximenes, the last of the Milesians. So the Milesians were around even before the Eleatics. Heraclitus. The Milesians answered no answer to this question, why things should not stay as they are instead of being subject to perpetual change. It occupied the attention of a solitary thinker of another Ionian town, Heraclitus of Ephesus, considered one of the Eleatics. So the entire notion of change and state are very complementary, and the conflation is usually, in terms of the intentionality, is like strictly equals, and extensionality is like same for all purposes, not different. Then the conflation is generally considered at least a partially mistaken metaphor that fails. It's not the strong metonymy, or otherwise these kinds of things. But it's also an important way then getting above this when they do lose their distinctness and become an amorphous whole of these things. That it's the view, the perspective, the projection. The projective and the perspective are key elements. It's not a common word, perspection, introspection, perspection. It's almost always usually perspective, and vis-a-vis the projective and projection. These are ways of also saying that geometry is projection and perspective. Pythagoras, the religious tradition. The mathematical universe. It is generally agreed that by the middle of the 5th century, they had arrived at most of the results which are systematized by Euclid in books 1, 2, 7, and 9 of his Elements, the Pythagoreans. This is a scientific achievement of the first order, but if you study their mathematics in the sober pages of Euclid's famous textbook, you will not recover its other aspect, the religious fervor with which their views were held. A quotation from a 5th century Pythagorean will help us to do that. Consider, exclaims Philolaus, the effects of the nature of number according to the power that resides in the decad. It is great, all-powerful, all-sufficing, the first principle and the guide in life of gods of heaven, of men. Without it, all is without limit, obscure, indiscernible. Sometimes it's called apeiron, which means, on the one hand, bad and infinite, and the other hand means good and infinite. Without it, all is ... The nature of number is to be a standard of reference, of guidance, and of instruction in every doubt and difficulty. Here he kind of just reflects that it's there for you. Were it not for number and its nature, nothing that exists would be clear to anybody, either in itself or in its relation to other things. You can observe the power of number exercising itself not only in the affairs of demons and of gods, but in all the acts and the thoughts of men, in all handicrafts and in music. Nor does harmony and the nature of number admit of any falsity. Nice. Falsity is in no way akin to it. Only to the unlimited, the unintelligible, the irrational do falseness and envy belong. Here these days, we've gone quite a ways beyond that, expanding the regular truth, the rulial, the regular, that defines that it's true. Things like there exist irrational numbers or there exist complex numbers in their forms, in their models, that yet for infinity, that infinity has got about the most going on with respect to the vagaries of conflation, the extent of limits, and all these kinds of things, which really make it so great. And it really speaks to the real importance of mathematical infinity, because when reality really is infinite, that's really what it is. So mathematics really has this great responsibility to physics to provide it all the mathematics of infinity, because it is real and it needs it. Practical. Points. Their points had bulk. They represent the triangular numbers. One of the most familiar numbers are the triangular numbers. Kind of like when you make Pascal's triangle and sum them up, you make the binomial theorem's coefficients and the expansion in the middle. But that the triangular numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, ... each of those partial sums help reflect, just the very basic nature of increment. Like if you're counting something as they come in, and there's either you have kind of like the respect of its number, or you have to recount every time that they come in. Add 1. Look, there's 1. Add another 1. Well, look, there's 1, but you've already counted now 3 to count it each time. So it just helps reflect that this relation in rate is geometrical. One of the usual thought experiments for sampling theory for statistics is called the balls and the vase. So a vase is a container, and it's opaque, and balls are simply small, non-distinct, each alike, otherwise individuals. And so the urn and the balls, or the vase and the balls, is the usual notion of how to show sampling with replacement and without replacement. So you might have red and green balls, or black and white balls, or these kinds of things. And the idea is then that you can insert balls into the vase and then pour them out, or whether how they're selected. And so some people think, well, I can just kind of reach in and grab the one I want. But that's not allowed. It helps to reflect that in this thought experiment, you can only insert one at a time or pour it out, and then it will come out in not necessarily the same order as they were inserted, one at a time. Mathematical relations now take the place of physical processes or states. Well, this is our attachment of mathematical models and physical models, and then usually as with regards to systems of units. The universe, so it appeared to the Pythagoreans, could be better and more quickly understood by drawing diagrams on sand than by thinking about phenomena like raised beaches, silting up of river mouths, evaporation, felting, and so forth. Herein lay a danger. This mathematical approach was adjusted both to the religious and social preconceptions of the school. Mathematics not only seemed to provide a better explanation of things than the Ionian view, it kept the souls of the brethren pure from contact with the earthly, the material, and suited the changing temper of a word in which contempt for manual labor kept pace with the growth of slavery. In a society in which contact with the technical processes of production became even more shameful, as being fit only for mechanical labor, it was found extraordinarily fortunate that the secret constitution of things should be revealed, not to those who manipulated them, not to those who worked with fire, but to those who drew patterns on the sand. For Heraclitus, who came at the end of a school of thought in which industrial technique had played a prominent role in providing the stock of ideas by which nature was explained, nothing seemed more natural than to regard fire, the chief agent in the technical manipulation of things, as a fundamental element. This speaks to our energia and dunamis and energia. Of course, you may be familiar with these previous talks covering quite a bit about these concepts, or not. But then as well, someone who's never even heard the internet may well have heard from the received wisdom this very notions, the elementary, and the assignment of the aspects of primary things, the primitive things, to all the things. The substitution of number for fire as the first principle marks a stage in the separation of philosophy from the technique of production. So here, when we have this kind of concept, what's the first principle and final causes, it goes back to kind of this metaphysical question, as of Nozick and Heidegger and Leibniz and so on, and myself, that what is above is what is below for the final cause and first principles. When they're conflated in the same, reversible, and holistic, has that vis-a-vis our numbers and what we have as our mathematical foundations today, and axiomatic set theory, descriptive set theories, or Middle-Franklin set theory, above that usual regular models of numbers and functions, and all such what arises from that, and the descriptive has this similar kind of notion in this separation in the philosophy. Because eventually there's at least one theory, and so everybody has a theory, and is there a theory for everyone that's true? Is a good idea to have if that's what your philosophy demands, that there exists in the universe, that the universe so reflects that itself. There's always room for monism. The deity is superscientific. In that sense, religions are cultural and social, and reflect common conscience in matters of reflection on the deity and their relation to man or to people. Thus, it's super scientific. While at the same time, we point to Hegel as kind of saying that we've achieved a science and a philosophy that allows us to have the teleological behind the teleological, behind then the ontological, while still having this common thread of truth, sublime, all the way down. So it's ultimately teleological, while yet objective, subjective, and ontological. Then it goes on to describe how musical instruments were formed, and it was possible to reproduce them simply by matters of their measure and form, that they had the same sound. Not that any two sounds are ever the same, but they wouldn't be different. You know. It is further remarked, they add, Brunet and Miele, that is to Pythagoras himself that tradition ascribes this discovery, a formal disproof of the belief affected by many of the Greeks about experimental science. And in this case, one may, with all probability, admit the attribution. Heraclitus is our kind of philosophical signpost for the dually self-infer-consistent monism, dual monism, or monist dualism. For the square of opposition and dialectic writ large. But everybody after that can pick that up and not need Carrot's attribution, because as a matter of plain definition, it is their own. It's to each their own philosophy. Parmenides, the attack on observational science. The indeterminate, condensation and rarefaction, or tension. The first to express an awareness of this distinction was the deep thinker Heraclitus. The eyes and ears, he said, are bad witnesses for men if the mind cannot interpret what they say. Of all those whose discourse I've heard, there is not one who attains to the understanding that wisdom is apart from other things. So wisdom is reflected as beyond intelligence and the ability to ascertain advantage in general sense and to carry action in the direction. Wisdom is considered the collection of experience and especially of that the abstract knowledge is applicable in wide experience. Empedocles and Anaxagoras to the rescue. He did not care for Parmenides, the old Anonians. So we've got started in talking about just the concepts of the theory and how they're so associated with concepts and theory. And that concept and theory is a theory and concept. And these sorts of things that always turn over that have to reflect the same thing, the same as the null and the universal, the same thing. Same with geometry is motion. Truth is regular. Geometry is motion. So in this sense, it's possible to kind of have mathematics and logic as truth is regular. And then the geometry is motion is kind of for the surrounds and also underneath that as well. So it's kind of a concept that restarts itself as it revolves. A revolution is a full 360-degree turn all the way back in the same direction. Such was the inevitable consequence of the impious attempt to establish a philosophy of nature. They didn't have a big enough library. They didn't have deep enough stacks. From this false start, mankind was rescued, according to this view of the history of thought, by the great Athenian moralist Socrates. He brought philosophy down from heaven to earth. Well, I don't know about that. Insisted that the proper study of mankind is man. Diverted attention from physics to ethics. Under his influence, philosophy abandoned its presumptuous attempt to understand the heavens and turned to the humbler task of teaching men how to behave as men. Here we'll leave that to Socrates and all such matters of conscience and conduct for morals and ethics, because it's also kind of variable. It's and there are constants, and what is good and virtuous is relative vis-a-vis the absolute. So here where our geometry in motion is dispassionate and it's totally reliable. You can trust it. You just can't really petition it, you know. This account of the relationship of Socrates to his predecessors is, in our view, false. The older natural philosophers did not concentrate on speculation about the things in the heavens to the neglect of human affairs. On the contrary, the original and characteristic thing about the Ionian way of thought was that it recognized no ultimate distinction between heaven and earth, that it sought to explain the mysteries of the universe in terms of familiar things. All right, and there's this sort of book is a great history of a lot of stuff that goes into it, and one thing about it is it gets in a lot of things that they're related. He mentions the Timaeus of Aristotle. And this is the mode of explanation of the universe in which he was systematically trained. The whole of its physics is also inspired and vitiated by the Platonic ideal. Amicus Plato is how Gadamer ends his study of Heidegger's Parmenides, which is kind of what we'll look at a bit here. So this is a great little book, Benjamin Farrington's Greek Science. With matriculation knowledge of these things, the horizons, Arctic circles, and so forth, he will be able to follow the book. But if he doesn't even know what a straight line is, or a curve, or a circle, or the difference between a spherical and a plane surface, he cannot even pick out the 7 stars of the barren night sky, my book will be of no use to him, or none just yet. He must first acquaint himself with the studies preparatory to a knowledge of geography. It's also this lack of preliminary training that makes the work of the authors of so-called harbors and coasting voyages incomplete. Strabo. Martin Heidegger. German, Austrian, in the area of the early 20th century, a Nazi, and so as we confiscate his thinkings, which are kept for the truth of them. Then at the same time we have apologetics, where apologetics is explanations. Apologetics isn't a forbearance or a pleading for forgiveness. It is in the usual sense. It's explanations. So, anyways, after World War II, Heidegger, he apologized. He kind of recanted in his participation in the Nazi Party. So he's basically put down for all that. While at the same time, just as the silver thread of the school comes through, that we don't burn books. We just kind of outline to disambiguate parts that don't deserve association. And so what this is metaphysics, Aristotle's metaphysics. So his great claim to fame was he was a great study of the classics. He was a classicist. What's a classicist? Well, they study Greek and Latin, so they can read Greek and Latin, because all the books that we had that came down in the West from ancient times were written in Greek or Latin. So, what are beings? Now this means, what is being? The reply to this question is really just a complete answer to the question concerning beings, to be sure. So Heidegger, he translates these classics, and then also reads his commentary as to associate with them. Ever since Parmenides, the battle over beings has raged, not as an arbitrary dispute about arbitrary opinions, but as diviatotaxia, as Plato said, as a battle of titans for the beginning and end in the Dasein of the human. So Heidegger, it's necessary to kind of find from Heidegger what he might have as wisdom that could be receivable. Oneness of being, not as genus, but as analogy. Here, for example, we're reflecting on geometry as motion, and that it's both. And so the genus is the ontology, and then analogy is like the metaphor, and both of those notions here eventually, ultimately, absolutely are not sufficient when they say that they fail. It's just that they're insufficient to say that they're totally complete and universal. I mean, it's not failing at something that's like easy. It's just not ultimately so that metaphor doesn't fail. Instead, the strong metonymy is real, is complete and absolute, and that this geometry in motion gets into then like all the geometry and its state and change and these kinds of things. This inquiry concerning beings is fundamentally an inquiry concerning being. So he talks about the principle of contradiction. There is no but, only yet. What I mean by that is that in many theories, you'd have a theory, and then you'd have some counterexample. You say, so this, but that, thus, either neither or one or the other. Whereas in the entire kind of theory, it's like, well, this, yet that. And then it has to be applied to all the theories. So in this kind of sense, for the temporal modality of all kinds of theories, then you could just say that there's no but, only yet. reflecting that. Marktigkeit, Marktabar, Herrscherkraft, Fähigkeiten, Severmogen, Befähigung. These being in reverse order: competent, the faculty of vision, psychic capacities, sovereign force, sovereign might, power. We call brutes despots, Maktaber, despots because they do not have power and cannot use it. Instead, they abuse it in the extreme because they possess only the means to employ violence. We could continue in this manner, only to exhibit the multiple usage of the word, only to demonstrate that we use different words for the same time for the same things. See, here this book is about force, and so force and power are associated, and in science, it's the capacity to do work. And so the Maktigkeit is like the ordering of things, and then it also reflects the rank and power of things, and so that gets into the capacity of things and their potential. So here we've already kind of framed this whole thing in a sum of potentials, and then that we have that our Newtonian force equals mass times acceleration, the usual equation, then is broken down in many, many ways to help reflect and relay that linear sort of impulse is just kind of a mark or a stroke in the entire world of the things. No, just the opposite. In order to see precisely, there are use of words such as force, craft, capacity, Fähigkeit, art, Kunst, talent, Begabung, capability, Vermögen, competence, Befähigung, aptitude, Eignung, skill, Geschicklichkeit, violent force, Gewalt, and power, Macht, is not completely arbitrary, and even when we substitute one for the other, for example, the power of sight, ability to see, faculty of vision, we still hear differences in this. We understand at once certain differences in each respective case. And yet how helpless we are if asked directly, what do you understand by power? What is called force? What does aptitude mean? Is it even possible in this way to define these expressions simply off the cuff without further ado? Here he writes ado, ADO, meaning without further consequence or thought. But it's originally adieu to God without further wonderment. So, with further ado, can the matter at stake in these words be grasped at all in the same way as the knife on the table or the book on the bench seat? And if not, then what is the point of searching? See, Heidegger will often just run out in his philosophy because then he's like, you'll keep reading, right? Because obviously I didn't make a point. Translated by Walter Brogan and Peter Warnock. So it's a great kind of thing to have when you want to study the ancient Greeks and their perspective according to the continental Germans of the earliest 20th century with regards to that being what we call philosophy today. So this is a book on the cosmology and the black holes and stuff. This is a little guy on motor vehicles. So the Automotive Handbook is a great thing, and it's produced by the automotive industry. And so it's got bunch of great little diagrams and stuff in it, technical optics. It's really just a handbook. And here's like all the chemical elements, their symbol type, atomic number, relative atomic mass, valence year discovered, discoverers. Curie, Dorn, Noddack, Wollaston, Bunsen, and Kirchhoff, Klaus. Ooh, the Rutherfordium's discovery is disputed. It was either Fierhoff or Ghiorso, it says, in 1964 and 1969. Berzelius, Crawford, Davy Ekberg, Segran Perrier discovered technetium in 1937. Hoffman and Armbruster discovered anubium, which has got a name now. I don't know what it is. 1996. And here's got the periodic table of elements. This, of course, is the coolest thing, I think, that people learning science, and then that physics is a thing, and then that chemistry defines the relation to elements for matter and substance. Besides it, physics is the whole thing. The chemistry for matter and the states of matter and the constituent elements of matter has that everyone at some point should be familiar with these. I don't know if I remember all the names anymore. See, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. It's tough when Na is for sodium and they start losing their relation exactly to their English words. Magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, and then I start losing it in the lanthanides. psyllium, titanium, vanadium, chromium, manganese, iron, CO is cobalt, nickel, copper is Cu is copper, zinc, galenium, germanium, arsenic, selenium, bromine, krypton. Then I'm really running out. Ytterbium. Why is ytterbium? Niobium, molybdenum, technetium, rutherfordium, rhodium, palladium, silver, cadmium, xenon. It helps to have studied these quite thoroughly and related them in a tabular function. Thus, that it's possible to understand then for all these being the way that chemical elements and their compounds are written in a usual normal form, then as for the naming and as for the International Union of Practicing and Applied Chemists, that they end up being able to read into these things. So there's an item in this here. Defines all kinds of material terminology, properties of gases. Acetylene, usually used in welding for oxygen and acetylene together for metalwork. Nitriding steel, case-hardened steel, rolling bearing steel, tool steel, allied cold work steel, hot work steel, high-speed steel, stainless steels, martensitic steel, austenitic steel, quenched, hardened and tempered, annealed. Hard metals, extremely heavy metals. Ooh, flywheel masses and counterweights. In the systems and the kinematics, then these material properties become relevant in how to draw a diagram, fill it up, put in its material properties, and find its material properties. It's been said that since about 2000, it is possible to make a thing, material science, with any given necessary physical properties. It would cost arbitrarily much in time and money, but it's possible to build physical things of arbitrary physical properties. It's kind of similar with the DNA and RNA and this kind of stuff. There is a lab, and what you do is if you have a DNA sequence, you send it the sequence, and they will send you it so assembled. I learned this in the university, in the biology department. My job was to write a front end for the supercomputer to run genome searches on human DNA. But it's a science, so it's kind of removed from the things. Metals, centered metals, soft magnetic, metallic materials, materials for direct current relays, sinter metals for soft magnetic components, soft magnetic ferrites, permanent magnetic materials. It's a great panoply of things, a great many things. Permanent magnets to soft magnets, solders and filler materials, electrical properties of materials, insulating materials, properties of non-metallic materials, ceramic materials, plastic, molding. Thermoplastic elastomers, plastic abbreviations with chemical names and trade names. So this is kind of where empirically then it's kind of so that all these kinds of things were, as they're eventually developed, they kind of have names, and they kind of have technical names, and they kind of have common names, but they're really just what they are besides their name. Epoxy, polyamide 46, it's called stenol, polyamide imide, Torlon, Dralon, Zytel, Vectra, Daplin, Trosoplast, Tedlar, polyvinyl fluoride, Bakelite, urea formaldehyde. So over time, these things were found to be developed, and then in given epochs and eras, that's the only way they could make something like that. So then everything was made out of that. Automotive paints, structured metallic coatings. So this is what we call sometimes finishes, like when you have a given part and then it's finished, like it's anodized aluminum, or whatever goes into making it so that the part has a given finish on it. Gets into what we have, what are called parts and assemblies, and then they make parts, and those are parts, and they make assemblies, and those are parts, and they make assemblies, and they make deliverables, and they make end items. So in a manufacturing process, it's parts and assemblies. And then there's like parts and carts and the jig and then when you get to assembling like the things, there's like the line or the bone for smaller and larger things that get made out of parts. Since it was invented for industry, these notions of specialization of labor and division of labor, and then the mass production of components with regards to specification and tolerances vis-a-vis everything being custom and bespoke. These are concepts that are usually known. Division of labor, specialization of labor, and mass production. They're often framed in terms of particular things like firearms or vehicles. Engine oils, all kinds of things about oils. 10 weight 5, 10 weight 20. Winter weight, oils. Get the right oil. Yes, sir. Consistency. Oh, greases. There's all kinds of greases so necessary. Whereas the oil is a viscous yet kind of fluid material, then grease is a viscous yet illiquid, non-fluid material. It kind of holds its state, holds its space. The notion of the machinery and equipment is really pretty cool with regards to all kinds of things go into it. Here it goes in describing a bunch of things to do with fuels. So fuels are used as a store of energy, and the conversion of the energy to other forms of energy, according to the geometry, what results? Motion. Fuels for spark ignition, environmentally compatible gasolines, environmentally compatible diesel fuels, properties of liquid fuels and hydrocarbons, antifreeze and brake fluid. Again, other materials, according to substances, their properties that do and don't burn, that aren't poisonous, that do and don't corrode, that do and don't do these things. So this is a great little book. And then here, for example, are all these standards. Overview of selected standardized non-electrochemical corrosion testing procedures. From salt spray to humidity, flowing liquids, sulfur dioxide, natural weathering test. Everybody should know the very basic notion of acids and bases vis-a-vis the percent hydrogen or pH and the scale logarithmically from sulfuric acid to sodium hydroxide generally. Vis-a-vis not just the effects of hydrogen, free hydrogen, or hydrogen donors or hydrogen acceptors, but also with regards to other things that result the corrosion behavior, or the opposite kind of collection. These are things. Heat treatment, quench and draw, annealing, hardness, tolerances, deviations, bearings, roller bearings. This is one of the greatest little books. When I saw this, I thought this was one of the best little manuals, the Bosch Automotive Handbook. Again, with an unfortunate association, kind of the technical and industry of the 20th century's sort of conflict, but still what it is. So this book is it's about in the 19th or 20th edition. The 5th edition from 2000. Moment in motion. Geometry is motion. So this book is it's by Ehrman and Stachel and Corcoran, kind of philosophers in physics, Americans, modern day, today, or recently, is into the 21st century. And it's a book about black holes from Oxford University Press in 1995. Aimed primarily at philosophers, prior acquaintance with relativity theory and secondarily at philosophically minded physicists. Makes no pretense at being a comprehensive survey of the subject. That there is one at all is something that people should know, that they have to make one, and that it can be. We have all these giants of men. We say we stand on the shoulders of giants. It's said that Newton said that if I have seen so far, it's only because I was able to stand on the shoulders of giants. So you got to get up there, and when you get there, then it kind of disappears, and it becomes just a picture of that you can see through. You know? So everybody needs to make their own theory, and the fundamentals and these principles go a long way to making it possible that having an objective philosophical foreground makes for that thinking people are still each so empowered to have this mental grasp and a facility for their own faculty, and their own trust, and their own object sense, number sense, and word sense, self-reliability and self-assurance, and as well to then be able to fulfill that kind of role among all sorts others. An essay in the philosophy of science and the foundations of physics. It seeks to assess the implications of space-time singularities and acausal features of relativistic spacetimes for the general theory of relativity and the philosophy of space and time. Singularities are these infinities. So if earlier in the conversation it was reflected upon that for the ancient Greeks that their mathematical religion was that they're to be avoided because they lose their fundamental character as perfect and immutable, has at the same time it's exactly what is to be kind of sorted out and figured out, and it's possible to start breaking it down, kinds of infinities, just like if there's a zero and it's a zero of what? It's like, well, it's an absolute zero of all the number space. What do you mean, 0 apples, 0 oranges? It's like, well, yeah, I suppose. It's like, well, you mean like, 0 numbers? It's like, it kind of starts, applying to itself. It's like, well, 0 infinities? It's like, well, I mean, you're talking about infinity zeros. Sure. See, that's one of the great things about it, is that it really just starts kind of open up. It's like there's an infinity of the things. It's real. It's mathematical. In the numbers, we got the pointed infinity. We got the compactification of the integers. There's a point projective and perspective infinity. Geometry is motion forever. Absolutely. Universally. As regards to this constant change and all the quantifiers in front, infinitely many. One, this is the great kind of notion of the concept that infinity at once is good and bad. So most people in English, American English, are familiar with the word infinity and its definition, at least from primary school. It is a word. It is given as a definition. It's not. It's important that a language actually have words to express things that are concepts. Otherwise it's kind of bereft. You can't really say a word that doesn't exist. So by the time numbers came around and it was established there wasn't a top number, then it was like, well, what's the top number? It's like, it's infinity. Well, I can increment numbers. What's infinity plus 1? It's infinity. But at the same time, in all sorts of manners, like after axiomatic set theory, we have ordinals and cardinals, and we have limit ordinals, and all these kinds of notions. Well, what about counting backwards? All these kinds of things really get into why infinity is a playground of the mind. And part of it is a real part, and expresses for this laws of large numbers. So in numbers, there's these laws of numbers and laws of large numbers. Usually one law of large numbers that induction affords building delta epsilonics for cases for infinite induction. Then after axiomatic set theory and the uncountable, we have also transfinite induction. But it's just making a case, and it carries for everything. Truth is regular. It's rulal. And so then for these different infinities, we kind of have different notions of continuity, like the line continuity, the field continuity, the signal continuity, after an integer continuum. And as for a long line continuum, that they kind of wrap together on the side to bring line continuity into field continuity and bring signal continuity into field continuity, all in the middle, the arithmetic and algebra. Infinity is great. So this book, all about singularities, is like, well, in all our formulas that we want to get around is like, anytime we get to an asymptote or singularity, whether that's division by zero or anything else that results kind of like a point of discontinuity on their formulas, is like, we need to frame all our notions of the absolute and the relative without having this, because some people don't have an object sense or a number sense or a word sense, whereas with regards that basically in our language, we don't have words for these things. And so this gets in a lot into the concepts and the conceits. And so let's see if it just shows up that he finds something that has to do with saying that it really must be. It really must be. Talks about tensors, which are objects and that they multiply together. They have products or operations defined on them, and they kind of carry it so that what's true geometrically on the one side is true after. So they're just abstract objects that happen to carry the properties of the geometric properties associated with the events come with them. Tensors. About the contravariant, the covariant, and the tensors. Because in general relativity, we have all these different coordinate settings, because it's like, well, whatever it is there in that region, it's got its own geometry, which really means its own shape, its own coordinate assignment to what are these field numbers to make the forces by their values in the fields. And so there's lots of formal work, which is of course necessary to get right, and it helps a lot to have learned to understand how to write these things in terms of trying to add them back up, to make a patchwork of these things, that piecewise their discontinuities are reconnected. And then with regards to things that are linear as through them, like the cube wall or that quadrature wall, or otherwise these things that are linear and nonlinear, or the centrally symmetric, as Einstein calls it, these are, this is all such matters of thinking about it. And that when they reach such an impasse, one of the first things that happens is then people spend forever just trying to turn it over in their mind. And so you get entire industries of books, either A, ending, or B, trying to explore this whole wider world, this wider realm of all these things. So we try to approach this kind of didactically, and from first principles for final causes, that this whole fundamental metaphysics arrives at this conflation ends up being okay, and it's possible to kind of have an actual approach to numbers great and small, and with regards to then not ending up adrift, and especially for things that would end up leaving physicists agog because mathematics just says we got nothing to say about it. That instead there is the real about this kind of thing that needs to be improved, and mathematics owes physics because it's missing out. So they can't make their claims to these greater completions, because by the time they introduce Jordan measure for line continuity, it's inconsistent otherwise with the mathematics that they built to rest their theory on, or Dirichlet and the signal continuity. They need these things. So I'm happy to have kind of written that up a little bit. It helps a lot to have this kind of context, to know otherwise it's like when to point out when something's missing, kind of where the perspective where it's from, the other side of the fence. And then for our styles, our little passages or our bridges from context to context, keeping it real, helping explain why things are intercompatible in this dually self-inferred consistent logic that's not paradoxical. These are the kinds of things that really help to have a coherent sort of consistent and non-contradictory, and to make for a common lexicon and regular vocabulary, that these things are regular and rulal again. Geometry is motion. One is thus led to wonder whether violations of causality can prevent the occurrence of singularities. No, one is thus not led. One might be led that way, but one need not follow that way, because ex falso quod lebe is this notion that, well, once you've made a mistake, you can then use that mistake because you consider it true to prove anything else that's entirely absurd. Well, no, that was still just a mistake or error, and it's ex falso quod lebe is truncated and make ex falso nihilum. Here, what's called classical logic today, with ex falso quod lebe and material implication, is named, its proper name, classical quasi-modal logic. It's not modal, it's not temporal, it's just a quick take on a simple linear algorithm to arrive at a certain form of syllogistic reasoning, quasi-modal logic. So we truncate that and we call it and say instead ex falso nihilum. We need to take any syllogistic reasoning and be able to reorder it. We pour all of its pieces into the vase and pour them back out in any order, and they still must say the same thing. That's more of a more relevant logic, you know. And there are many different things that are called logics, you know, which are just basically truth tables, what result, or the derivation of inference. And so it's much better to have like true logic in this kind of sense. So one need not be led necessarily, although we have induction and inference and deduction and inference and abduction and theory and these kinds of things, and it's great. But this kind of just reflects on that. This philosopher is struggling a lot with not really come to terms, and so it's not really clear if it's just kind of like, so why don't you keep reading and think along with me vis-a-vis don't. So I'm really again I'm kind of looking to D'Espagna and his philosophy of physics, which is from 2000, that starts very conservative but is trying to pull some of these things together as helping improve the discussion about physics and philosophy, and to help put aside some of these notions that arise after the 20th century, like multiple worlds interpretation or quantum indeterminacy or this and that, which because our theory of free will does not need it to be exercised, that a lot of the fantastical things and anything that's paradoxical is kind of poo-pooed. And that modern mathematics with better infinities helps resolve these things instead of just coattailing the wallpapering. So these are great books, and they really do help reflect a lot of all the mathematics that does stand up to attain to arise to how to deal with then these formulaic approaches and all that what gets into when it's all very linear and easily connected to very well understood pieces of the common linear curriculum. So in this manner, it's okay. See, that's pretty much what I wanted to look at today were those books. I kind of picked them out. Here's T.E. Home, and he has his three continuities, and so he's kind of an artist. To describe the nature of the activity you get in art, the philosopher must always create some kind of special vocabulary. Here there's that mathematics is a universal language, so it's pretty cool. Has to make use of certain metaphysical conceptions in order to state things satisfactorily. I like that. Poem of the Cid, the great heroic poem of Spain from about 1000 A.D. The immortal legend of a Spanish knight who vanquished the Moors with his fearless sword and forged the feudal Spanish states into a great medieval nation. A Mentor classic. English verse translation with the Spanish text on facing pages. Kelfa, Fries, and Gave, Cid and Alcocer, They set up their tents and built an encampment. His family and the principal Christian knights. Minaya, the Cid wounds Fariz. Ooh. The king allows the Castilians. Now, I haven't read this, but it's sort of a history. And then what we're kind of most familiar with, or it's a very regular concept and notion, is Don Quixote. Don Quixote is a story of an old man, and he has an idea fix, and with his great companion, he takes out on a quest, and to fight the giants, so these windmills, and it's generally reflected upon that it's kind of there's literature, and that it's to be reflected as if it were so, as if that his theory that is true to him, vis-a-vis the usual parable that it's like he's delusional. Both of those being perspectives on the thing, and so his idealism is its own perfection, is all that is. Geometry is motion.